Good morning, everybody. As Renee said in his introduction, my name is Karina Martinez, and I'm one of the data managers on the GlyGen project. I am here at the George Washington University in Washington, D.C. And today I will be going over searches for Glycan exploration on the GlyGen portal. So first off, this is the GlyGen.org homepage, and I want to just point out a couple of things. So we've got these cards on the webpage that will take you quickly to many of our searches and tools, and we've also got some statistics here on the side. So currently we've got a little over 46,000 glycans and almost 98,000 proteins in GlyGen. The database statistics here on the right shows the number of glycans, proteins, and glycoproteins for each one of the organisms in GlyGen. And now I will be moving on over to the Glycan searches. So you can initiate a search either from this Glycan search here on the front, or if you go to Explore and then Glycan Search, it'll take you to this page. This first tab is what we call the simple search, and you can type any category of information here in this box, including enzyme, glycan, organism, protein, or if you keep it with the any tab, it'll search any of those fields for the information that you type in. So if you know your GlyGen accession number that you're looking for, you can go ahead and type that in right here. I'll go into the GlyGen numbers a little bit more in a moment if you're not familiar. And click search. So this is the glycan that I was searching for, and this is the Glycan details page. On this page, we've got lots of different information on a particular glycan structure, and it starts here with an image. So this is the cartoon according to the SNFG nomenclature. If you need more information about any of the sections on the website, we have these tooltips here. So it links to the GlyGen wiki page, and there's information on each one of the fields in that particular section. So as I mentioned, the cartoons are graphical representations of the glycan structure according to SNFG, and there is a link here as well. So I'll just briefly talk about this. This is a standardized glycan structure nomenclature for drawing the specific monosaccharides that are included in a glycan structure. So each monosaccharide residue has a particular shape and color, and there are standardized rules included on this page for drawing these structures and designating the linkages. You're able to, these figures are able to show varying levels of definition. So if you've got a known monosaccharide residue versus a residue that is, the class, but not the specific type of glycan, it can show that as well. So just wanted to point this out so that you know that this resource is available and you can get to it from that wiki page. All right, so coming back to the details page, we also have GlyGen accession numbers. These are our main identifiers for the glycan structures in GlyGen. And So GlyGen is a repository where any glycan structure can be registered and a session number will be generated. Again, you can have fully defined structures where all of the residues and linkages are known. And you can also have unknown linkages and lesser defined residues as well. So we use these GlyGen sessions. Moving along, so you've got lots of information here about, we've got mass, glycan type. The next, we've got our feature viewer section, and here you can use these checkboxes to highlight the different parts of the glycan structure. So for instance, hexose, this is the class of monosaccharide residues. It'll show you all of the hexose residues in this highlighting here on the right, or if you'd like to just see the mannose or galactose, you can do that as well. You can also look at motifs, and Nathan will be talking more about motifs in his upcoming talk, but for now, I will just point out that you can use this feature viewer to highlight just the motif. And we also have an enzyme viewer, so you can click on the residues that are synthesized by specific enzymes here, and it's separated by organism. We have, for instance, human, mouse, etc. Okay. We also have a 3D viewer for all of our fully defined structures. So again, those are the structures that all of the linkages between the monosaccharide residues are known, and each one of the residues is also known. The organism section lists the different organisms that this glycan has been identified in, or and this is also listed here through, we use subsumption, which Nathan will be talking about a little bit during his talk as well. But the source is listed here for all of our organism information. So you can actually click on these badges and get to the source where this information came from. If there's a name for this particular glycan structure, it would be here. We've got motifs listed, so any motifs that are present in the glycan will be in this section, and you are able to click on the ID and it'll take you to a motifs detail page. So I'll come back to that after we go through this page. Associated proteins, so these are proteins that are reported to be glycosylated by the particular glycan structure, and the information includes the position, if it's known, and the organism. And Renee will be talking a little bit more about the site page and site search for the proteins. Okay, some of our glycans also have glycan binding protein information, and we have biosynthetic enzymes listed as well. These are all of the enzymes that are known to synthesize the structure. Okay, subsumption, I mentioned that briefly earlier, and the information that we have here on the Glycan details page includes ancestors of the particular structure that you're looking at. So these are, because the one that we have up on the screen is fully defined, it will have ancestors that are, for instance, topology means that this is the same organization, but the linkages between the monosaccharides are unknown. We have composition, so this structure, the monosaccharides are known, but the linkages are unknown. And base composition means that the classes of monosaccharides are known, but the specific residues themselves are unknown. And then descendant would be if you had a structure, for instance, one of these, it would show all of the descendants. I will point that out a little bit later when we're looking at Glycan details page for a composition Glycan. All right, we also have biomarkers now listed on GlyGen. So any biomarkers that include either the glycan or the protein will be listed in this section here. We have expression information from tissue and bodily fluids, as well as cell and cell line expression. The digital sequence section includes IUPAC, works, and glyco-CT strings, as well as INCHI, GlyCam, IUPAC, and SMILES. And we have lots of different cross-references. So these are now organized according to the type of cross-reference. So you can cross-link to these other databases. For example, we've got KEBI and PubChem links, KEG, Sandbox, other, Glycan, glycomics, glycoproteomics, and ontology and dictionary cross-links as well. The history section shows when the Glycan was added to the database, and the publication section lists all of the publications where this Glycan structure has been identified. All right, so moving along, I would like to go over the motifs page next. So I'm going to click on this motif ID. There we go. Okay, and this is the LACNAC motif. Lots of information here as well. The Glycans with this motif section lists all of the Glycans that we have in GlyGen with this particular motif. And we also have a biomarker section. So any biomarkers with that particular motif would be listed here, as well as the digital sequence, cross-references, history, and publications. Okay, then let's see here. Let me oh, there we go. Move that. Okay. I want to briefly go over the biomarker details page as well. So this one, for example, is a glycoprotein biomarker. This is the circulating CD44 V6 variant and sialylated TNO glycoform panel. Each one of the biomarkers will have a description. It'll have the information from the literature where this biomarker was, where they mentioned that this was a biomarker, and we've got the source information under these badges as well. Under the components section, we have both the glycan and the proteins that are included in a particular biomarker, and any cross-references and publications that are associated with that biomarker as well. Okay. The next thing that I'd like to go over are the other types of searches that you can conduct in GlyGen. We already talked about the simple search, so next I'd like to go to the advanced search. So you can conduct a search according to the Glycan ID, which can be just a single Glycan ID or multiple Glycan IDs using either GlyGen accessions or other cross-reference IDs. The Glycan ID namespace here allows you to specify which namespace you are using for your cross-reference IDs. There are selections for mass, number of sugars, organism, the type of glycan, glycosylated protein, binding proteins, motifs, enzymes, PubMed IDs, and biomarkers as well. So just to show you what it looks like when you conduct one of these searches, I'm just going to search for all of the glycans that are glycosylate this protein accession number here. And this is the Glycan list page. So whenever you conduct a search, this is your results page. On the left here, we have lots of different filters where you can dial down your results to specify organism, glycan type, sequence details, etc., and all of the glycans that match both your search and your filters. The hit score here will place the glycan structures with the most information at the top. So you can actually hover over the question mark here and see exactly how that hit score was determined. And you've got a snapshot as well of the information about each one of the glycan structures. All right, and I'm going to briefly go over the composition search as well, because we'll be doing a composition search as part of one of the exercises today. And Nathan will be talking a little bit more about the composition and structure searches during his talk as well. But the composition search here, you are able to search based on the residues in a structure, and you can change the contains to maybe, yes or no, and define a minimum and a maximum number of residues and get all of the structures that meet that criteria. There's also a load template option. So we have some N-glycan examples here, as well as O-glycan. So if you would like to search for, for example, an N-glycan, trimenosyl core, we can say, yes, if it's the same number here in minimum and maximum, it'll look for structures that have exactly that number. Or if you just want, at least 3, then obviously you can remove the maximum and it'll autofill with the maximum that you can go to here. All right. So next up, we are going to go over a couple of exercises. These were sent out in an email, and the link should be available. Let's make sure that that is in the chat so that everybody has those materials so that we can walk through a couple of searches together. I'm just going to pull it up here on my screen as well. And in the meantime, if anybody has any questions, feel free to unmute yourself or stick it in the chat.
Okay, we already had some questions related to the composition search in the chat, but I think you answered most of them. I just put the links to the exercises in the chat again. So when you click on that, you will end up with a folder with 2 PDF files. One has glycan in it, one has protein in it. You want to open the one with the glycan in it, and that gives you, well, Karina will guide you through that part.
Okay. Okay, so your Glycan, excuse me, your Glycan exercise should look like this. And the first search that we are going to do is in the advanced search. The task is to find all fully defined sialylated N glycans that have been reported in humans and have associated glycosylated proteins. So there are step-by-step instructions on the handout. If you need to go back and refer to those later, you will, from the homepage, navigate to this Glycan search. So again, explore Glycan search from the main menu, and then tab over to advanced search. So to find the human glycans, you can specify the organism. There's a nice drop-down menu here. Change that to human, and we will select N-linked from the glycan type. Once you select one of those, you can also select a subtype if you would like, but for the exercise, we're just going to go ahead and click search from here. Might be, oh. Okay. So the initial results give us 10,721 results. So next, in order to specify that we only want fully defined glycans, we can go down to the sequence details filter and click fully defined. It's now 776 results, and we are looking for only those glycans that are sialylated. So you can go to the by monosaccharide filter here and select the mu AC. Okay, so now we're at 368 fully defined glycans that have a sialic acid, and we next want to know which of these glycans have glycosylation associated proteins. So by clicking the glycosylation filter, we are now looking at 167 results. Any questions at all before we move on to the next exercise? Okay. Make sure there's, okay. All right, you can either start a search all over again by going back to explore Glycan search, or you do have the option of just modifying your search. So that will take you back to the search page, and it'll keep the selections that you had already made. If you'd just like to make some, keep most of those, make some changes, but we're actually going to be moving over to the composition search for this next exercise. So exercise 2, our task is to find the glytucan accession for the bionic string hexNac2, hex2, dhex2, and identify the fully defined structures with this composition in mouse. So this is sort of a two-pronged search. First, we want to find the glytucan accession for this base composition glycan. So if you're running a mass spec experiment and you get a bionic string, you know the composition, you can just enter that in here. So we have 2 hexNac, and we're going to change that to yes. Because it's a specific number, we'll change the numbers on the min and the max. and do the same for hexose and deoxyhexose. Then click search glycan. Might be going a little bit slow since we're all running it. So I do have my list here from earlier. I'll just use this for now. Okay, so our results, we've got, should have 192 results from that composition search. And in order to find the Glycan accession, we want to select base composition from the sequence details filter. And this will give us only those glycan structures that have the classes of monosaccharide residues. I don't have the results for this one already pulled up, so I think it might be going a bit slow if we're all doing the search at the same time. Okay. All three images, it might just be taking a moment to load the other images, but all three will show up here as well. And here we go. Okay. So as you can see, there are three different structures that appear here, and you might be wondering, okay, well, what is the difference between these? So this one in the middle here, you've got one reduced residue, but we're looking for just the unreduced structure in this example. So we want the Glycan accession that corresponds to the structure that does not have any linkages that are known. So one way to do that is you can hover over the hit score. So you see here, this first one does have some defined structural information, and this one down here does not. So this is likely the one that you'll want to pick. Let me open this up real quick as well. And earlier I mentioned that I would talk about the subsumption a little bit when we were looking at one of these composition glycans. So in this case, because this is the base composition, it has the least amount of known information for this particular structure. Under subsumption, it lists all of the descendants of this particular combination of residues. And you can see all of the structures, whether they are fully defined or partially defined, that are descendants of this structure. And another way to just verify that this is the base composition glycan that we're looking for, if I look at one of those descendants and I go to the subsumption, the ancestor for the base composition should be that structure that we selected, which is this accession ending in WZ. So that matches this one right here. Okay. And then the next part of the exercise asked for all of the fully defined glycans with this composition that are found in mouse. So let's go ahead and switch the sequence details filter to fully defined and uncheck base composition. And select mouse. Okay, so there is our final answer. We have two fully defined structures in mouse that match this particular composition. So again, if you're running an experiment and you are looking for potential candidate glycans with that composition makeup, you've got a couple of options here in the search results. Okay, so that brings me to the end of my presentation today. So the last 20 minutes or so of my talk will just be a Q&A session. So please, anybody, if you have any questions, feel free to unmute yourself and ask, or you can put it in the chat as well.